Earth's magnetic field is the basis for all modern navigation, from airplanes to satellites in space and ships at sea. If it continues to deteriorate, those systems and more are at risk.
Nothing is as fascinating as the looping magnetic field lines surrounding our Earth like a protective kernel. The magical force field protects our planet from scorching solar winds and radiation. But recently, scientists have noticed a loophole in this structure. A loophole that might doom all of humanity. Plus, the magnetic field is doing something it hasn't done in the last 750,000 years. What is this loophole in the Earth's magnetic field, and why does it exist? What strange thing is the Earth's magnetic field doing now? Should we expect any consequences? Join us in this video as something strange is happening in Earth's magnetic field, getting scientists worried. The Earth's magnetic field is one of the protective mechanisms put in place by nature to protect humans and all other bio-life forms on Earth. The dense field deflects high-energy particles from the sun, allowing only harmless low-energy solar radiation to get to us here on Earth. Earth's magnetic field is generated in a complex process scientists call the geodynamo process. I'm sure you know that in physics, you can use electric currents to create magnetic fields. The motion of charged electrons causes a magnetic field to form in perpendicular circles around the electric source in obedience to Faraday's law of induction. So picture this. Our planet rotates and generates electric current just the same way electric current is generated in a self-powering dynamo. This generated electric current then gives rise to the magnetic field. And so, you can say that the Earth is a natural, self-powering dynamo. Not all planets can generate their own magnetic field. Mars, for example, doesn't have a protective magnetic shield like Earth. The truth is that the molten iron and nickel mixture in the Earth's outer core play a vital role. A planet must have a liquid core and rotate at a reasonable speed before it can be a geodynamo. As the Earth rotates, a convection current is generated in its liquid outer core. The motion of these convective currents gives rise to the magnetic field. But then, another force comes into play here. This force is responsible for arranging the magnetic lines and unifying them to function as a whole. This force is called the Coriolis effect. The Coriolis effect theory holds that the gentle movement and rotation of iron and nickel in the Earth's outer core helps create a solid, unified field of magnetic lines of force on the inside of the core. The same Coriolis effect causes the magnetic lines of force to loop back down to connect with the originating points in the field. This process makes the Earth a dipole, like a bar magnet. The velocity of flowing liquid iron in the outer core causes the Earth's magnetic axis to tilt at an angle of about 11 degrees. This is also relative to the Earth's rotational axis. Just so you know, this outer core of our planet contains mainly hot, liquid iron. The temperature here is an insane 6,000 degrees Celsius, so hot that it nearly surpasses the sun's temperature. Thanks to this heat, the iron and nickel found here are kept in their molten state, allowing them to flow with a velocity relative to the Earth's spin. Earth is one of the few planets in the universe with an ocean of molten iron deep beneath the surface. Although this liquid core zone is responsible for generating our magnetic field, it turns out that the magnetic field generated is not always uniform. Scientists have spotted a wide region of low magnetic intensity in our magnetic field. The region, which spreads across a major part of South America and Southwest Africa, has been noticeably growing in recent months, and experts are worried that it could have dire consequences on our planet. Scientists are calling it the South Atlantic anomaly. In case you're wondering, this isn't normal, and yes, it can have dire consequences. You see, without the Earth's magnetic field, our planet would be no different from Mars. Experts are afraid that the growing anomaly could allow harmful solar rays to creep into the affected regions. Another terrifying fact is that the SA anomaly is spreading. What if it one day becomes so massive that it engulfs the Earth and forever leaves us at the mercy of the scorching sun. Scientists have discovered that the anomaly in the Earth's magnetic field is caused by a huge geofeature in the African continent. About 2,900 kilometers below the surface, scientists have found a massive reservoir of dense rock called the African Large Low Shear Velocity Province. A large low shear velocity province, also called LLSVP, is a huge structure deep within the Earth's mantle. These structures are called low shear because seismic shear waves travel more slowly through these regions than on normal mantle. Geologists believe that large low shear velocity provinces act the way they do due to their unique temperatures and composition. Now, you may be wondering where LLSVPs actually fall in the order of the Earth's interior. To understand better, let's analyze the Earth as a sphere with different layers. The Earth is divided into 5 major parts: the crust, the upper mantle, the lower mantle, the outer core, and the inner core. The upper and lower mantle, collectively called the mantle, is a region of hot, semi-molten rock that hardly moves. The mantle is where seismic waves travel through. Scientists study these waves to learn about the design and structure or nature of the Earth's interior. Studying these waves also allows geoscientists to understand and predict things like earthquakes and volcanic eruptions. Large low shear velocity provinces are usually found at the base of the Earth's mantle. Aside from the African LLSVP, another one has been spotted beneath the Pacific Ocean, called the Pacific LLSVP. It's still a mystery why these 2 locations are the only known places to possess these low shear velocity structures. But in any case, their presence highly influences the movement of material within the Earth's mantle. Research has shown that the African LLSVP is millions of years old. It extends several thousand kilometers across. Scientists believe the position of this province between the mantle and outer core gives it a chance to disrupt the motion of the molten core. This, therefore, disrupts what would have been a smooth magnetic field generation. Experts fear that the disruption in the magnetic field will gradually cause a progressive weakening of the Earth's magnetic field. No one knows if, over the next decade, the Earth's magnetic field intensity will have degenerated to a deplorable state. If such happens, there's no telling how bad things may get for us Earthlings. Many things can make the South Atlantic anomaly expand. One such thing is the trapping of solar particles and plasma from the sun. You see, not all solar particles are repelled by the Earth's magnetosphere. Some actually seep through, while a majority of it gets trapped in between the Van Allen belts. The Van Allen belts are zones of energetically charged particles captured and held in place by the Earth's magnetosphere. The inner radiation belt starts at about 645 kilometers from the surface of the Earth. Sometimes these belts can confine solar particles, bouncing them to and fro the magnetic field lines. And so, it isn't uncommon for the Van Allen belts to become highly energized during solar storms. In such moments, the South Atlantic anomaly may get warped more than usual and become even weaker. As a result, more solar particles will seep into the atmosphere through this weak point. Conspiracy theorists have suggested that the South Atlantic anomaly may be the reason for the increased heat experienced in several parts of the world, like America. Many experts also believe that the increased levels of radiation experienced by spacecraft or satellites positioned in the lower Earth orbit are all due to the ever-growing South Atlantic anomaly. All these, though not adequately proven, may not be far from the truth. If only scientists knew how to get rid of this anomaly, they would have. However, there's still a lot of mystery behind this phenomenon, and experts have their hands full trying to figure it all out. In 2016, a study revealed something shocking about the South Atlantic anomaly. It was moving. As impossible as this may sound, cooperative investigations by other research teams actually proved it to be true. It turned out that the anomaly was drifting in the northwestern direction. By 2021, it was officially established that the anomaly was drifting about 0.23 degrees south and 0.34 degrees west per year. Another shocking revelation was made by the European Space Agency that the South Atlantic anomaly was dividing into two parts. A quick investigation by NASA also confirmed this disturbing event. Part of this divided anomaly has been found to be slowly drifting towards southern Africa at the rate of 20 km per year. As a result, the magnetic field over southern Africa has weakened noticeably in recent times. However, the good people of southern Africa may not feel the effects of the dwindling magnetosphere like satellites in orbit. Satellite probes and other devices in orbit are way more vulnerable to solar radiation escaping through the South Atlantic anomaly than humans are. Recently, it's been reported that the International Space Station is suffering increased levels of ionizing radiation. Many experts in the scientific community have attributed this to the South Atlantic anomaly. This increased ionizing radiation is causing equipment damage and operational issues. Certain instruments on the outside of the space station, such as the Global Ecosystem Dynamics Investigation, or GEDI system, have been known to experience disruptions. Radiations are causing interference to the GEDI detectors. Prolonged interferences can cause data loss and other complications that may necessitate the periodic shutting down of the system. But despite all this, there's still more to come. You see, the South Atlantic anomaly is not a recent development. Many experts in the scientific community have proposed that it may be a periodically occurring magnetic event. These experts suggest that the anomaly may have appeared several times over the course of the past 10 million years or more. This implies that the South Atlantic anomaly, or SAA, is not occurring by chance. It may be a seasonal change in the magnetosphere. Some experts even suggest that it may be connected to the periodic flipping of the magnetic poles. One unique thing about the Earth's magnetic poles is that it isn't stable. Scientists have learned that the magnetic poles shift over time, and sometimes they even switch places. Just imagine if the Antarctic was no longer where it is today, but actually switched places with the Arctic. The Antarctic and Arctic are polar opposites located on opposite ends of the globe, but their contrast goes beyond mere location on the map. While Antarctica is a continent surrounded by oceans, the Arctic is actually an ocean of ice surrounded by continents. Of course, these two places can never switch, right? Well, in a sense, they can. Scientists have discovered a phenomenon called the geomagnetic reversal. This is a phenomenon in which the North and South poles switch places with each other over the course of several years. Scientists have observed that our North Pole is constantly shifting. This was first detected in the year 1840. Since then, up until 2022, the Earth's North Pole has moved a total distance of 2,100 kilometers. At first, no one could understand why this was happening. But later on, experts in the scientific community realized it was due to a periodic process called geomagnetic reversal. Before now, nearly 2 centuries ago, Canada was the prime location of the Earth's North Pole. Now, it has shifted to Siberia. But that's not all. The North Pole is shifting at an alarming rate too. Previous data from the early 90s depicted its rate of motion at 16 kilometers per year. However, recent data has shown that the pole is moving at a rate of 55 kilometers per year. That's a massive acceleration right there. And so you may ask, where are our magnetic poles running to? And what is the Earth really trying to achieve with this feat? The Earth is simply trying to do what it has done several times before: reverse the magnetic poles. Thanks to deep research, experts in the scientific community have found out that the Earth has reversed its magnetic poles 183 times in the last 83 million years. And members of the scientific community have agreed that we are beyond due for a geomagnetic reversal. Now, you may be wondering how researchers managed to come up with this number. The secrets all lie in the Earth's surface iron. When volcanoes erupt, it doesn't just spill only molten rocks. There are also traces of molten iron flowing freely in it. However, strangely, these traces of iron always orient themselves in the direction of the Earth's magnetic field. Knowing this, scientists observed the deposition of iron on the Earth's surface and noticed something peculiar. They observed that some layers of ancient rocks had iron particles pointing one way, while some others had particles pointing the opposite way. This could only happen if there was a flip in the Earth's magnetic poles. By counting how many such reversed layers of geologic history were detected, scientists were able to come up with the number of geomagnetic reversals as 183. They also learned that these reversals usually occur every 450,000 years, but the last few ones had 300,000-year intervals. However, despite these numbers, it turns out that the last known geomagnetic reversal occurred about 750,000 years ago. So, you can say we're overdue for a reversal. Many in the scientific community believe another geomagnetic reversal has already begun. This is evident in the shifting of our planet's north pole. For now, no one knows what causes these flips on the Earth's magnetic poles. However, there's one theory. This theory suggests that a kind of reaction or interaction between the mantle and the outer core causes a fluctuation in the spin of molten iron. As the flow pattern gets disrupted, the magnetic field lines are no longer unified and slowly begin to take random forms. It's like the whole magnetic field goes into confusion. Over time, things may settle down, and the spiraling lines will arrange themselves. But when this happens, the poles would always end up in new positions, and so our North Pole may end up reappearing in the geographical south of the globe. Overall, this fluctuation and reversal process can take up to 10,000 years to complete. But it's not the switch in polar positions that's the terrifying issue here. It's the process itself that poses the real threat. A lot can happen during a geomagnetic reversal that can threaten our existence. One unsettling fact about the geomagnetic reversal is that it causes a massive drop in the Earth's magnetic field intensity. Experts at NASA and other space agencies have concluded that the Earth's magnetosphere can drop to as low as 10% of its ideal strength during these events. It's mind-boggling, but shockingly, that's our current situation. Already, we've seen the South Atlantic anomaly cause severe consequences to our atmosphere. Now, if the overall strength of Earth's magnetosphere drops to 10%, we'd be at the mercy of solar flares and unforgiving radiation. Auroras could be seen in parts of the world where they never used to appear before, and skin cancer would become more prevalent. Our satellites and probes up there would sustain even more damage. From fried circuits to malfunctions and breakdowns, all man-made space objects would suffer. Astronauts and cosmonauts would be unable to explore space or stay at the International Space Station due to the destructive solar flares. Moreover, our electrical grids would be a lot more vulnerable to solar storms, making for more frequent blackouts. In short, life on Earth, as we know it, would change. But that's not all. A research team from the University of New South Wales in Sydney has found new evidence to link one of the magnetic field turbulence events of the past to the massive extinction of some ancient Australian species. A few mentions among these species include the giant Australian wombat, also called Diprotodon sculpture, and the giant kangaroo. It is important to note that these creatures didn't go extinct during a full-blown magnetic pole reversal. Instead, it was a period of wobbling and turbulence in the magnetic field lines, a phenomenon scientists term geomagnetic excursions. These sorts of events happen over shorter time frames, like a few hundred years, unlike full reversals that may take 10,000 years or more. The scientists believe that during the Los Champs geomagnetic excursion, there was a spike in the radioactive carbon levels in the atmosphere, and it was all thanks to the chaos in the magnetosphere. Animals couldn't adapt to this change, and so some species died off. Now, we don't know what to expect in this unraveling geomagnetic reversal, but if these scientists are right, then given the depleted ozone layer and a host of other climate issues already on ground, even the human population may be at risk of extinction. The scientists published their study in 2021, and though the timing of the extinction of these species and the geomagnetic excursion lines up perfectly, not all in the scientific community agree with their claims. Scientists have not found any other geomagnetic reversal or excursion events that resulted in the loss of a species, so the Loophole event may just be a coincidence. Also, the extinction event the scientists pointed out was only native to Australia. There's no evidence that the same scenario played out in other parts of the world. All these facts have made many experts dispute the study. Many folks in the scientific community believe that most of the geomagnetic reversals have come and gone without harming human life or species. However, this doesn't take away the fact that certain inevitable harm and damage will befall our infrastructure. Several experts predict massive destruction of satellites and space probes, climate shifts, and so on. Surely, the process will be bearable, but very uncomfortable. The big question is, should you be worried? The answer is no. At least we don't have to do much to prepare for a reversal. That's because geomagnetic reversals take place over thousands of years. Yeah. The average lifespan of a human is 80 years. This means that by the time you're old, the polar shifting would have progressed to a negligibly small extent. In truth, we may not even get to witness the Earth's magnetic field strength drop to 10%. That may only happen in the next few thousand years. By then, we're long gone. So, it's safe. Moreover, even if our future generation were to get caught in the middle of a reversal, they could still make amendments to the technology of the time. For instance, they could build better shields for satellites and other space probes, or they could make better sunscreens to reduce the danger of skin cancer. Most of all, the Earth's magnetic field isn't the only layer of protection. There's the ozone layer. Our atmosphere is built to trap radiation, and going by scientific calculations, the ozone is expected to last the next 10,000 years. So, unless our estimations are wrong and we're already far into a colossal geomagnetic reversal event, there's no cause for alarm. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.